So now I want to talk about infinite limits. That means the limits equals infinity or negative infinity, which is related to the topics about the vertical asymptote. So in the pre-calculus, let's look at an example. In the pre-calculus, we know that, for example, f of x equals 1 over x plus 1. Okay, so how to find the vertical asymptotes? So we have, if this is the simplest form, so that means you cannot simplify anymore, then you set the denominator to be 0. Then you solve for x, so x equals -1. So x equals -1 would be the vertical asymptote for this function. So this is the vertical asymptote. Okay. So now let's look at another example. If we know the graph or function, which is given by this one. So from this graph, we notice that if this is c, this is corresponding to the x equals c. The limit as x approaches c minus. So as x approaches c minus, that means from the left side of c, right? So the points on the curve will go up along the curve without any bound. So it will go up forever. So we can say that the limit as c approaches c minus, as x approaches c minus, the limit of f of x would be equal to infinity. Okay, so the similar situation, let's look at the limit as x approaches c plus of this function f of x. It will also be, so this is the approach of c from the left side or right side of c, and it will go up along the curve, right? So it will also be infinity. So here, infinity is a symbol, not a number. Okay, it's not a number. Okay, so since the both one-sided limits had the same result, infinity, so we can also write this one as the limit as x approaches c of this f of x is equal to infinity. So this is the one example for the vertical asymptote, right? Let's look at another example. This is also a vertical asymptote, right? From this case, if this is c, the limit x approaches c minus of f of x is equal to what? Positive infinity, right? The limit x approaches c plus of f of x would be negative infinity, right? So let's look at why it's negative infinity. So this is the approaches c plus, then the points on the curve will go down along the curve, go down forever, right? So for this case, it's still a vertical asymptote. Another example, this is also a vertical asymptote. The reason is as x approaches c minus of f of x, which is equal to infinity, although the limit as x approaches c plus of f of x is not equal to infinity, positive infinity or negative infinity. So here we say the positive infinity is the infinity. Okay, from these examples, we notice that if one-sided limits is infinity or negative infinity, then this x equals c would be, this is x equals c, which is a vertical line, would be a vertical asymptote. So this is the definition for the vertical asymptote. So we say x equals c is called a vertical asymptote if fx approaches positive infinity or negative infinity as x approaches c from one or both sides. Okay, so this is the definition. So now let's look at some calculations about the infinity. Before that, let's recall something. If you have a fraction a over b, this fraction, if a, b are positive numbers, okay, a, b, positive. If b is decreasing, then a over b would be increasing, right? Okay, so this is a very important property we will use. The denominator is decreasing, then the whole fraction would be increasing for the positive fraction, right? So now let's look at some calculations about the infinity. So this is the theorem. So suppose we know that the limit x approaches c of f of x equals infinity, and the limit x approaches c of g of x equals a finite number L. We use less than infinity, that means it's a finite number. Then the first result is the limit x approaches c of f of x plus or minus g of x. We know from the property we can distribute the limit for each one, right? So it becomes the limit x approaches c of f of x plus or minus the limit x approaches c of g of x, and we know this is infinity plus minus L. No matter how large L is a finite number. So infinity plus or minus a finite number would be what? Infinity. The finite number will not affect the infinity if you add or subtract this number. Second, the limit x approaches c of f of x times g of x. So it's equal to the limit of f of x times the limit of g of x. So this is the infinity times L. So you should be careful. If L is, so we have two cases. If L is less than 0, then this would be a negative number times positive infinity would be negative infinity. If L is greater than 0, it's a positive number. A positive number times a very large number, it's still a very large number, so it's positive infinity. But pay attention that I didn't see anything about L equals 0. So we will not discuss the case for L equals 0. That would be another story. Okay, so here we assume L is not 0. 3. The limit x approaches c of g of x over L f of x. So we have the limit of g of x over the limit of f of x. So this is the L over infinity. So here, infinity, that means the denominator is very large. So here, let's record this result. So this is the b is decreasing, then a over b is increasing, right? If b is increasing, then a over b would be decreasing. Okay, so this is for a, b are positive numbers. So here it doesn't matter. So L is positive or negative because the denominator is a very large number. For example, if you have a plus or minus a number 2, okay, this is L over a very large number, 1, 0, 0, 0, 0. You have many zeros. It's a really large number, right? It will very close to 0 at last, so this would be 0. So a fixed number over infinity is 0. So here are 3 rules, right? Infinity plus or minus a fixed number equals infinity. Infinity times a fixed number, if this number is less than 0, it's negative infinity. If this number is positive, then it's positive infinity. L divided by infinity would be 0. Okay,